Hello everyone. Today we are going to discuss about what is law of conservation of energy. What is law of conservation of energy? In that only meaning is that energy is conserved. Energy is conserved. We can't create the energy and we can't destroy the energy. But energy can transform from one form to another form. First of all, what is energy? The capacity to do work. The capacity to do work is called energy. Then what are the types of mechanical energies? There are two types of mechanical energies. One is the potential energy, another one is the kinetic energy. The capacity to do work, suppose one person is there, he is having more capacity to do work. So you can say that person is having more energy like that. But we are going to discuss about belongs to mechanical energies, and we are giving one of the example, law of conservation of energy. One example is in the case of freely falling body, it is following the law of conservation of energy or not, we are discussing now. See, first you know that what is energy. There are two types of mechanical energies are there now. What are those? One is the potential energy, another one is the kinetic energy. What is potential energy? The energy possessed by a body by virtue of its position, that is called potential energy. Potential energy, we can take it mass into acceleration due to gravity into height. In terms of when the body is having the energy due to its position, the energy possessed by a body by virtue of its position, that is called the potential energy. In our daily life, where we should observe the potential energy, if the water is coming from height to down, in the case of waterfall, due to the height difference, it is getting the energy due to the height difference. That type of thing we can take as a potential energy. The energy possessed by a body by virtue of its position. Even you press the football also, it is getting the energy, but the ball is there only because of its position. This is getting the energy. That type of energy is called the potential energy. Then what is the formula for potential energy? Mass into acceleration due to gravity into height. Like that. Kinetic energy. Kinetic energy, it is the another type of mechanical energy. We can write it half into mass into velocity square. The energy possessed by a body by virtue of its motion. River water is one of the examples. Suppose you are running, you are having which energy? You are having the kinetic energy. Vehicles are moving from one place to another place. Sometimes they are arranging the lights in that due to the kinetic energy. Their kinetic energy is converting into like a light energy. That light is illuminating. All belongs to kinetic energy. So these two are two types of mechanical energies. One is the potential energy. Another one is the kinetic energy. Now how to find out the total energy? Total energy equals to potential energy plus kinetic energy. Potential energy plus kinetic energy. But our question is, we should discuss the freely falling body. In the case of freely falling body, what happens? Look here. This is freely falling body and it reached to the ground. This is the ground. Consider this is the initial point A, and in between we should consider one more point B. On the ground, this is the point C. Height from A to C, height is h. When the body is freely falling means the initial velocity is 0. When initial velocity is 0, there is no meaning for. If the velocity is 0, there is no meaning for kinetic energy. But we can observe only one energy here at the starting point, that too it is a freely falling body. So at A, what is kinetic energy and what is potential energy and what is the total energy, we should find out. At A, what is potential energy? Easily we can say that mass into acceleration due to gravity into height, because height is h. Then in this case, kinetic energy equals to half into m into 0 square, because velocity is 0 means kinetic energy is also 0. So the total energy in this case is total energy equals to mass into acceleration due to gravity into height. From this here what we should observe, the entire energy is in terms of potential energy, and here there is no kinetic energy when the body is at A, because it is freely falling body and it maintains how much height it is coming from, how much height h is the height. Then at B, now the body is coming from A to B, means it covers a small distance we should consider, that is the x. From B to C means from ground, how much height it is maintaining? It is maintaining the height h minus x. In this case, what is the potential energy? Potential energy equals to mass into acceleration due to gravity into, but the height is h minus x. So it should be right, mgh minus mgx. But what about the kinetic energy? We can't say here this is 0, it is having some velocity. It reached to the point P and it is covering some distance, and we can go for initial velocity at point A is 0. We should consider Vb it is. We can use third equation of motion, Vb square minus 0 square equals to 2 into g into distance travelled is x. This is the velocity. Here kinetic energy is Ke equals to half into m into, instead of Vb square we should write it 2gx. 2 cancel. You are getting this is mgx. Now we know the potential energy and we know the kinetic energy, and we should concentrate on total energy is how much? mgh minus mgx plus mgx. After simplification you will get it, in this case total energy equals to mgh. This is equation number 2. Here it has both potential energy and it has the kinetic energy. Now we can go for case 3. When the body is reached to the ground at C. At C clearly there is no height, so potential energy is equals to 0. Potential energy is equals to 0. But what about the kinetic energy? We can calculate from B to C and from A to B. Anyway, it is 0. Starting velocity 0 means it is easy to find out the velocity when we are taking the initial point A. So we can use from, we should consider velocity is Vc. Vc square minus 0 square equals to 2 into g into, don't take the distance x, we can take distance is nothing but height, 2gx. 2gh. This is the Vc square. Now kinetic energy at point C equals to half into m into Vc square is 2gh. After simplification, here kinetic energy is mgh. From this what you are understanding? The entire energy is in terms of kinetic energy when it is on the ground. When at point C there is no potential energy. Anyway, finally we are getting total energy also. Once again you are getting mgh. From equation we are taking equation 1, 2 and 3. At A also total energy is mgh. At B also total energy is mgh. And at C also total energy is mgh. So total energy is conserved. So in the case of freely falling body, we proved that energy is conserved. We can't create the energy, we can't destroy the energy, but it can be transformed from one form to the another form. We can take many types of energies: mechanical energy, kinetic energy, potential energy belongs to mechanical energies, then chemical energy, nuclear energy. Finally, the conclusion is we can't create energy, we can't destroy energy, but it can be conserved from one form to the another form. Here we proved that law of conservation of energy in the case of freely falling body. Thank you.